Let's go ahead and take a look at this here. So here we are offered a recursive form of the sequence here. So they're not giving us the actual sequence. We're given our recursive form. So in this case, if we want to find a of 5 in this case, we do have to create an explicit form. So let's do it here. We want to go ahead and create an explicit. And in order to do explicit form, we have to identify our first term and our common difference. Good thing for us in this case is that they're actually already given it to us. A1 does represent the first term. And in this case, 3, positive 3 represents the common difference. Common difference. All right. So in this case, let's go ahead and build the equation there. So I have a of n equals 5 plus a 3 times n minus 1. All right, and that would be our explicit form. That is once again the explicit form. All right, now if we want to find a of 5, which means the fifth term of our sequence here, all I have to do is substitute. So I have a of 5 equals 5 plus a 3 times 5 minus a 1. So in this case, that's 5 plus 3 times 4. 3 times 4 is 12, and that would give us 17. So a of 5 in this case equals 17. All right. Once again, just another way for us to write the explicit form from a recursive to explicit. And if they're asking for a certain term in the sequence, then we need to make sure we do have the explicit form. Or you could actually just count from 5 going on to the fifth term and then just adding 3 4 more times. All right. So that's example 3. And this is your practice problem. So this is something for you to work on. All right, so this is for you to work on. This is a you do. All right, and I do have one more example. Once again, this is just converting back and forth from recursive to explicit. So recursive in this case, guys, they're going to be giving you your first term and your common difference. This here, once again, represents our first term. And this right here represents the common difference. All right. So if we want to write it in explicit form, once again, all we need is our first term. Plus our common difference. In this case, it is a negative 10, so that's actually going to be minus 10 times n minus 1. And there we have the explicit form. Once again, that's 1. If we want to show the second form, we have to distribute the the negative 10. And then combine like terms. So second form there would be negative 10n plus 15. So either of these two would be an answer. All right. So let's take a look at this last one. A of n equals 20 plus 2 times n minus 1. If we want to express this as a recursive, we need to identify our first term and our common difference. All right. So in this case, guys, once again, the first term is always going to be the constant, or most of the time it's going to be the constant in the sequence. I say most of the time because if we take a look at this one here, for example, 15 is not the first term. It's actually 5. So if you have the expression non-simplified, which means it's not distributed, then you could actually easily identify 20 as your first term. And in this case, guys, the number that's being multiplied on the outside of the parentheses, or the one that has the variable, if it's simplified, is your common difference. So this one here is our common difference. Common difference. So let's go ahead and write that down. First term here is 20 plus 2 here, which is our common difference, and that's all we wanted to find. Okay. All right. And I do have a challenge problem for you guys. If you guys get it, that's amazing because we're actually working backwards. So here is your challenge problem. And I want you to do recursive form, which in this case talks about identifying your first term and the common difference. So that's the little challenge for you guys. So I want this.